And so this lesson is on perpendicular lines. Your EQ, what are the key ideas about perpendicular lines? All right, so we have some vocabulary here just to start. Perpendicular lines, those are lines that intersect at 90-degree angles. And there's a picture there, shows you two lines that are perpendicular to each other. And the little box, that means that those are right angles, 90-degree angles. If you're writing out that two lines are perpendicular or two segments are perpendicular, then the symbol you're going to use is a upside down capital T. All right, that means that the two figures are perpendicular. And what that looks like, for example, is maybe you have line L is perpendicular to line M, or you can have line XY is perpendicular to segment AB. So when the difference between that last example, XY, that's a line because the arrows are on the segment above it, where AB is just a line segment, there is no arrows. So that is a specific length of a part of a line. Okay, and so two lines are perpendicular when they meet at a right angle, 90 degrees. And to find a perpendicular slope, when one line has a slope of m, remember we use the letter lowercase m for slope, a perpendicular line would then have a slope of -1/m. So that's called taking the negative reciprocal or the opposite reciprocal. If you have a number, and remember slope is just a number, if that number happens to be an integer, it's not a fraction yet. You can always take any integer and turn it into a fraction by putting 1 in the denominator. All right, and then taking the reciprocal means you flip it. And then changing the sign is what else you want to do. So we started with positive m, and that was an integer. Think of it as being over 1. You would then flip it to be 1/m and change it to a negative. If m was a fraction, like 1/3, then when you flip it, you would get 3/1. Okay, so reciprocal means to flip it, and then negative or opposite, you got to change the sign. That's okay, Alicia. Okay, so interactive slide. Can you do this? What is the negative reciprocal of -1/4? So you guys are going to your Pear Deck slide, your presentation, and you're putting in a answer for what you think it is. All right, so -1/4. There is only one correct answer of 11 responses so far. You have to take your fraction, you have to flip it, and then change the sign. That's how you take the negative reciprocal or the opposite reciprocal. Okay, so we're going to look at some responses because they really are all over the place. It looks like maybe this is a -40. So maybe someone was trying to type -4. I don't know how that, or 40. Those are way off. But the reddest dot right here appears to be at 4, which is correct, +4. So if you take 1/4 and you flip it to take the reciprocal, you get 4/1. 4/1 is just 4 divided by 1, it's 4. Your answer won't have a fraction. Yes, it won't let you do that. So the answer is +4. +4. All right. Moving on. So here are some examples. This is a fact. Perpendicular lines have opposite reciprocal slopes. Perpendicular lines have negative reciprocal slopes. You have to change the sign and flip the fraction. Now, that's the difference between that and parallel lines. Remember, parallel lines have exactly the same slope. But perpendicular, it's the opposite reciprocal. So if you look at this picture, we have a green and a blue line graphed. And if we want to find out if they're perpendicular, well, let's take a look at this blue line first. You could find the slope of any line with a picture if you take 2 points that intersect the grid and you count rise over run. All right, I can see that this line is going up and to the right. The blue line is, so it is a positive slope. And I'm going to count my rise. So starting at the lower point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is my rise. And now that I'm level with the other point, I'm going to run to the right to get to it. 1, 2, 3, 4. Rise over run. 12 over 4. What does that simplify to? You could type it in the chat. What does 12 over 4 simplify to? You're right, Veronica. It is 3. Okay, 12 over 4 is the same as 3. So the slope of the blue line is +3. If this green line is perpendicular, which it kind of looks like it is, right? But I don't see any right angles here. So if it is perpendicular, then its slope would have to be the opposite reciprocal of 3. It would have to be, so you have 3, think of it as 3 over 1. It'd have to be 1 over 3, and then it'd be the opposite sign. So it'd have to be -1/3. So we're going to see if this green line has -1/3 slope. Well, it is going downhill, so it is negative slope. And if I start at the lower point and count up till I'm even with the higher point, 1, 2, 3, and then so that's, the rise is 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. -3 over 9. Is that the same as -1 over 3? What do you guys think? You could say yes, you could say no, you could do thumbs up, thumbs down. Do they have the same value? -3 over 9 and -1 over 3. Yes, they do. Yes, they do. Okay, so we've just shown that these are perpendicular lines. They meet at 90-degree angles because their slopes are opposite reciprocals. So that's with the picture. And now over here we have an equation, y equals 3x minus 9. What's the slope of that line? What is the slope of y equals 3x minus 9? Just type it in the chat. Somebody tell me, what is the slope of y equals 3x minus 9? It is in slope-intercept form. Thank you, Veronica. Yes, the slope is 3. So on this next slide, I want you to write me an equation of a line that would be perpendicular to y equals 3x minus 9. You're going to go to your Pear Deck tab and type something in now. Yes, Jason, that is slope-intercept form. That's right. y equals mx plus b. That's good. And I know you're just typing in the chat, but it's all lowercase. Certain variables in math have to stay a certain case. All right. Like we just learned about midpoint formula, and that was capital M. So lowercase m is slope. Like a whole decoding type thing. All right, I have 9 responses. Let's see, what are we coming up with? I see a deleted response. Y equals. So you could type, or you could use the writing tool. That slope-intercept form, yes, y equals mx plus b. See, it's all lowercase, just like that. So what would an equation of a line, and there's actually an infinite amount of answers, okay? I have to change something about that equation to get the right slope. My slope is 3 because 3 is the coefficient of the x term. And if I want the opposite reciprocal of 3, turn 3 into a fraction by putting a 1 in the denominator. Flip it and change the sign. Aha, right here, look at that. Y equals negative 1/3 x. Nice. Plus 9, that works. There we go. Y equals negative 1/3 x minus 9. Also works. Okay. The y-intercept could be anything you want, as long as the slope are opposite reciprocals. The intercept, I'm just asking for any line that is perpendicular to this line. So the y-intercept could be anything. If I was asking you about a specific point that is passing through, then we're going to have to restrict our y-intercept to something else. But the way this question is phrased, just write an equation. There's an infinite amount of answers. So as long as you have negative 1/3 x as your slope and something else here, then you're good. All right. So we're going to move on to our next slide. And this is what I just mentioned. This is a more specific type problem. So find the equation of the line, there's only one, that is perpendicular to y equals negative 4x plus 10 and passes through the point 7, 2. If I ask just for an equation of a line that's perpendicular to a line, there's an infinite amount of numbers, choices. Because you can think about a possible line, like here is the line y equals negative 4x plus 10. So this yellow dashed line is the line that I'm looking for that passes through the point 7.2, but if I didn't restrict it to passing through a certain point, you can think of this line essentially like sliding up the blue line or down, and there's an infinite amount of choices. But there's only one line that's going to pass through 7.2 and be perpendicular to this blue line. And so we're going to figure out what the equation is of this yellow dash line. Well, we are given the original slope of the blue line, which is the coefficient of the x term. Your slope is always the coefficient of the x term. So my slope of the blue line is negative 4. So what's the slope of my yellow line have to be? Because I'm thinking I want it to be perpendicular, so I have to take negative 4. And I have to change it so that is the opposite reciprocal of negative 4. Think of negative 4 as being over 1. Flip the fraction, change the sign. So we get 1/4. Veronica got it too. Thank you. Good. Yes. So the slope that we started with on that blue line is negative 4. If I take the negative reciprocal, I get positive 1/4. So the perpendicular line will have a slope of 1/4. Now that I know the slope, we got to figure out the rest. I have a point. They're giving me a point, and I have the slope, so I use the point slope form. This is one way of showing you guys. So I showed you that with parallel lines. So we're going to do kind of the same thing, but this time we have perpendicular lines. But I already figured out the slope, but now I'm going to go back to what we did before with parallel lines, and I'm going to plug it into the point slope form. All right, point slope form is y minus y1 equals m times x minus x1. And if you guys remember back on parallel lines, that comes from the slope formula. Okay, so if I'm given a slope and a point, I can use this formula by replacing the slope with what they give me and replacing the x1 and the y1 with the point that they give me, 7, 2. 7 is the x coordinate because the x coordinate is always first. The y coordinate is second. And so 2 goes here and 7 goes here. So that's substituting into the point slope formula. And once you've done that, I mean, that is technically true, but it's nice to also be able to put it in slope intercept form, y equals mx plus b form. And to do that, we actually have the distributive property right here. 1/4 times x minus 7. So we're going to multiply 1/4 by x and multiply 1/4 by 7. 1/4 times x is x over 4. 1/4 times 7 is 7 over 4. We keep the subtraction sign here. And then to simplify this equation that we have in blue now, what we need to do is combine like terms. Constants are like terms. Minus 2. This is a constant. Minus 7/4. This is a constant. There's no variable. This term has a variable x. This term has a variable y. But this term and this term are alike, which means we can combine them. So I want y by itself because I'm trying to get into this form. So I need to get rid of this minus 2. Inverse operation says I should add 2 and add 2. If I add 2 to negative 7/4, or think of it as 2 minus 7/4. 7/4. So if I'm trying to work with fractions, how can I turn 2 into a fraction that has 4 as a denominator? I'll just type this in the chat real quick. So 2 as a fraction with a denominator of 4. So when you want to change a whole number into a fraction, you multiply by 1. But the form of 1 I'm going to multiply by is 4 over 4. Because I want 4 in the denominator. So 2 times 4 over 4 is the same as 8 over 4. Right? Because 8 divided by 4 is 2. So 2 is the same as 8 over 4. 8/4 minus 7/4. When you subtract back fractions, you only subtract the numerators. 8/4 minus 7/4 is 1/4. So after all of that, here is the equation. And you can see that that is the equation of that line right there. Okay, it's crossing the y-axis at 1/4. And then my slope is positive 1/4. So I rise 1 unit and then I run 4 over. I rise 1 unit and then I run 4 over. Oh, I went too many. I'm going to show you. So if you want to quickly check if 2 lines are perpendicular, say you're just given 2 equations. Are they perpendicular? Take a look at their slopes. See if they are opposite reciprocals. You know, you can multiply the 2 values together, and if you happen to get -1, it means that they are. That's one way to tell. So this all works really nicely unless you have a vertical line. Vertical lines are parallel to all other vertical lines as long as they're not the same line. And then vertical lines are perpendicular to horizontal lines. Okay, so remember, horizontal is side to side, vertical is straight up and down. One way you can remember that is like horizontal, I always think about the word horizon. If you look at the horizon, okay, like where the sun rises or the sun sets, it's going this way. Horizon, horizontal, and vertical is the other one. Whatever helps you remember. That's how I remember. All right. Okay, here you go. Last question. Are these lines perpendicular? True or false? Wait, I phrased that wrong, huh? If it's a true false question, it should be a statement, not a question. It should be a statement. These lines are perpendicular. This is why I teach math and not language arts. So I'm saying the statement is these lines are perpendicular. Y equals 14x minus 8 and y equals negative 14x plus 6. Are they perpendicular? Is that true or is that false? Look at their slopes. Look at the coefficient of the x terms. First equation, 14 is the slope. Second equation, negative 14 is the slope. Are 14 and negative 14, are those opposite reciprocals? More of you guys have this wrong at the moment. Now we're even. 10 of you are true, 10 of you are false. This is false. Okay? This is absolutely false. For these two lines to be perpendicular, one of these would have to be, they're opposites. 14 and negative 14 are opposites, but they're not reciprocals. The reciprocal of 14 would be 1 over 14. So not only do they have to be opposites, they also have to be reciprocals for it to be perpendicular lines. Alrighty, so that is the end